Hello, ladies and gentlemen. Today we are going to take a look at making our own common denominators. So how do we add and subtract rational expressions? How do we make a common denominator so we can add these fractions together? So remember, we're always working toward this goal of being able to simplify rational expressions accurately. So simplify these fractions correctly and accurately using everything we know about fractions, adding, subtracting, multiplying, and dividing them, as well as how to factor. So let's think about what it means to be like terms again. What if you have 3 cows plus 4 cows? Well, you'd have 7 cows, right? 2 cows plus 3 ducks has to remain 2 cows plus 3 ducks. There's nothing I can do there because they're not like terms. The same thing goes with fractions. 1/5 plus 7/10 can't be added together because we're not talking about the same thing. There's fifths here and there's tenths here. We need to make these denominators be the same. So remember back in your earlier grades, you'd say, well, what do I have to do to make common denominators? What's an appropriate common denominator for these two fractions? Well, you might say 10 because you can turn this 5 into a 10 pretty easily by multiplying it by something, by multiplying it by 2. The bottom gets multiplied by 2, or 2, and the top gets multiplied by 2, making this fraction turn into 2/10. So now we can add it to the 7/10, creating 9/10 as my total answer. Now notice once the denominators were the same, I just added these numerators together, right? And I kept them as tenths. The denominator didn't change. The same sort of idea remains for what the types of fractions that we're working on are these rational expressions. In order to add or subtract them, we have to first make common denominators. We have to make that common denominator by multiplying by something on those fractions. And whatever we multiply the bottom by, we have to multiply the top by as well. And to do this most efficiently, we're going to need to rely on our factoring skills. So let's take a look at 4 examples here today. The first example asks us to add these two fractions together. 4x plus 1 over x squared minus 4 plus 3 over x minus 2. Well, notice that the denominators here are not the same. And we can't just square them to make them be the same. All right, because squaring isn't a way that you make common denominators. You can multiply them by something, but squaring isn't that. So what do I need to do then to make common denominators happen here? Well, let's first decide what is in the denominator of this first fraction. Notice it's x squared minus 4. Well, that is better known as, or factored to be written as x plus 2, x minus 2. This is his factored form. It's equivalent to x squared minus 4, but in this case it actually helps us to look at this guy separated as his factors, because then I can decide what kind of lowest common denominator I would need to have or make in order for these fractions to be added together. Notice how this fraction has an x plus 2 and an x minus 2. This fraction only has an x minus 2. What kind of denominator would I have to have, or what would happen, or how would I make them be the same in order to have this common denominator? Well, you might say the second fraction, all he's missing is that x plus 2, and then he'd look exactly the same as this, right? That's that act of making a common denominator. So the lowest common denominator we're going to use has both x plus 2 and x minus 2 in it. So my fractions then will get rewritten with both of those in their denominator. Here we go, x plus 2, x minus 2. So notice how I've changed my fractions here to reflect what my lowest common denominator is going to be on the bottom, but now I have to decide if I need to change the numerators at all. This first fraction already had x plus 2 and x minus 2 in the bottom, so when I rewrote it over here, I didn't put anything new, so I'm going to change his numerator by nothing, essentially, right? Change it with nothing. We didn't change the bottom, so we don't change the top. However, the second fraction here only had an x plus 2, or sorry, x minus 2. The x plus 2 that we wrote is now new to that second fraction. So we need to multiply the top of that fraction by that same thing. So this then becomes 3x plus 6. So now I have made common denominators, and I've changed the numerators to reflect how I changed the denominator. Now I can just add these fractions together and done, right? That's all I have to do is just add the fractions together. So how do you add these numerators? Well, you add like terms. What's 4x plus 1 plus 3x plus 6? 4x plus 3x would make 7. Oops, that's a funny 7. 7x and 1 plus 6 would make 7. So this is the new numerator of my fraction. Now it could be that I could break apart that a little bit, factor it. If I take a 7 out of that, he turns into 7x plus 1 over x plus 2, x minus 2. Done deal. There's my final answer. Okay? When we look at that, making that common denominator, we're going to try to make those denominators be the exact same and look the exact same with the same factors in the bottom. So let's take a look at a second example here. This one is x plus 5 in the bottom of his fraction. The second one has x squared plus 10x plus 25. Notice that this is not factored. Our first step would be to factor him. Try to figure out what is he made of, like what's going on there. So what multiplies to make 25 and adds to make 10? 5 and 5, right? So this guy splits apart into x plus 5, x plus 5. So what denominator will need to be on the bottom of each of these fractions? Notice how this fraction just has one x plus 5. This fraction has two x plus 5s. So we would need our common denominator. What would I need to make in order to, make these guys look alike? Well, this second fraction kind of is okay, but the first fraction, all he would need is an extra x plus 5 on the bottom, right? So my common denominator is going to be the x plus 5, x plus 5, just like that second fraction. Now, once I decide that, I just multiply the top by whatever I added or essentially put on the bottom. So this first fraction only had x plus 5. I now made it be 2x plus 5s. So I need to multiply the top by an extra x plus 5, making him 4x plus 20. The second fraction didn't really change. He had both of those x plus 5s. So that's not going to change his numerator at all. And now I just go ahead and subtract those fractions. Be careful, we're subtracting here. 4x minus 6x is negative 2x's. 25, or sorry, this is 20, isn't it? Whoops, 4 times 5 is 20. 20 minus negative 1. 20 minus negative 1 is positive 21 because it's minus a negative is like adding. And the bottom just stays the same, x plus 5, x plus 5. So here is my simplified answer after I add or subtract, in this case, those two fractions. Let's take a look at third example, 3 out of 4 here. All right, the bottom of this fraction is already x plus 4. He doesn't need to be factored, right? Because there's no squareds in there for me to break apart. And this one is x minus 3. So good news is I don't have to do any factoring. What would my lowest common denominator or the denominator of my fractions have to have? Well, this fraction has an x plus 4. And this fraction has an x minus 3. Those are two very different things. They are not the same, and there's no way I can make one turn into the other. So what I need to do is use both of them as part of my lowest common denominator. X plus 4 and x minus 3 are going to be on the bottom of both of my fractions. So notice how I changed the first fraction from just x plus 4 to now x plus 4 and x minus 3. So I totally put this other x minus 3 there. That means I have to change the top of that fraction by that same thing. So it becomes 3x minus 9. Well, the second fraction, I put an extra x plus 4 down there, so I need to do that same thing here. That becomes 8x plus 32 when I distribute. So now to add these two fractions together, I'm just going to add like terms. 3x plus 8x is 11x's. Negative 9 plus 32 is 23. And the denominator, x plus 4, x minus 3. Done. This is my simplified answer, adding those two fractions together. Okay, let's look at fourth and last example, ladies and gentlemen. This one has 3 fractions. Don't worry, it's okay. we're still going to do this same strategy. Anytime I want to look before I make common denominators here, I want to make sure there's nothing that it can factor. But I see all three of these, there's something I can do to break them apart. This first fraction, ladies and gentlemen, I could take a 3 out, making him x plus 3. This second fraction, I can split apart into x plus 3 and x minus 3. And this third guy, I could take an x out, leaving me x minus 3. Whew, there's a lot going on. But I'm going to have three fractions to work with here, and they all have to have the exact same denominator. So this first fraction has a 3, so my lowest common denominator must also have a regular 3 out in front. He also has a parenthesis x plus 3. Nice. My second fraction has x plus 3. I already have that in my list, right? He has an x minus 3. Okay, I have to put that down there because it's not in my lowest common denominator yet. And the third fraction has a regular x out in front. Is that in my lowest common denominator yet? Nope. So I better put that in there. I think I'm going to put him in front here with this 3. Just kind of plop him in front. And it also has an x minus 3, but I already have that in my list, so I don't have to list it again. So this is my lowest common denominator. This is what goes on the bottom of each and every one of these fractions, ladies and gentlemen. Sometimes that lowest common denominator has a lot of pieces to it, but it's okay. Remember, we're just adding these fractions together. We're just going to change the top and add like terms. All right, so now we just need to figure out what we need to multiply the top by in order to change it. So this first fraction had 3 and x plus 3 already. What's new in the bottom of the fraction that he didn't have before? This x is new, and this x minus 3 is new. So I need to multiply this x by another x, times x, and then times an x minus 3. So this becomes x squared times x minus 3. That becomes x to the third minus 3x squared. The x squared times the negative 3. So now we did the first fraction. Now let's look at the second fraction. What's new in the denominator for that guy? He had x plus 3 and x minus 3 already. So what's new is this random 3 here and that x. So I need to multiply this by 3 and an x. Well, 1 times 3x is just 3x, so that's not so bad. What about the last fraction here? What's new to him? Well, what's new? I'm comparing. I'm just looking across my screen. He had an x, and he had an x minus 3. So what's new is x plus 3 and this random 3. So I need to multiply him by a random 3 and an x plus 3. Well, 4 times 3 is 12, so this is 12 times x plus 3, making 12x plus 36. So now when I go ahead, I've done all the hard work now, I just need to add this stuff up. So all the way across the top here, adding these like terms, I'd have 1x to the third minus 3x squared plus 15x's, 3 of them and 12 of them, plus 36. Nice. And on the bottom, I have 3x, x plus 3, x minus 3. Perfect. I have added those fractions together and found that simplified answer. All right, ladies and gentlemen, this is what we'll be doing, making common denominators and adding these fractions or subtracting these fractions. It takes a little practice, and you'll get better at it each time you do them, okay? I want to thank you for taking good notes. Kincaid out.